Don't forget to put the date on top of your paper. Today we're going to talk more about frequency tables, which you may remember from a couple of videos ago. And then we are going to talk again about histograms as well. So just to keep us kind of in context of where we've been and where we're going, we've been talking about dot plots, we've talked about stem and leaf plots, and those were both for for quantitative data. We talked about bar graphs, we talked about pie charts, and then some frequency tables and some relative frequency tables. And if you remember, we talked about those in terms of categorical variables. Well, now we're going to talk about frequency tables in terms of quantitative variables. So this is table 1. It's a little bit confusing because it's centered. Well, it's supposed to go with this. So it's kind of a frequency table, but really what it is it's telling us, assuming, of course, that you've already read the question, which you should do. So this is going to be the state and then what percent of people who are born outside of the United States they have. And this was from, it doesn't have a date. It says a few years ago. I do think it was more than a few years ago. I think these numbers have gone up since, at least in most states. You know, it would be interesting to pull the current data and do a kind of comparison. That would be kind of fun. Okay, so let's go back to the question at hand. It asks us to talk about the individual and the variable. Haven't talked about individuals in a while. Remember that individuals don't have to be people. So in this case, they're the states. And the information we're collecting about the states is what percent of their residents were born outside of the United States. So that's the variable that we're trying to measure here. So this is great and all, but let's make a histogram to more easily interpret the table. There is a difference between a histogram and a bar chart. A histogram is for quantitative, a bar graph is for categorical data. So that's the difference. And then we'll talk about the difference in what they look like here in a second. So first thing we need to do is decide how wide our bins are going to be. Remember, we've talked about bin width before. So the key thing, and there's not really a good rule of thumb, okay, but the key thing here is you need to choose bins that are small enough that we see a shape, but large enough that they include multiple data points. So if you make them too big, then you're going to just see like 2 bars. And if you make them too small, they're all going to have just one little data point in them. So you kind of have to find a happy medium. And I'm going to argue that let's just do groups of 5, because I think the lowest here is like 1 something. Is there anybody that's in the 0? I don't think there's anybody in the zeros. So there's a 1.2 here. West Virginia might be the lowest. And then the highest one, I see a 27 in California. It might be the highest one. Okay, so let's just do groups of 5. Now, there's 2 options here. I want you to look at those 2 options and think about what the difference is. I either go from 0 to 5, 5 to 10, 10 to 15, or I go from 0 to less than 5, 5 to less than 10, 10 to less than 15, etc. The issue that I have with option 1 is, where do you put, if there was somebody who landed exactly 5.0, where does it fall? Does it go in the first bin or the second bin? By writing it like this, I know that someone who is at 5.0 falls in this one, because it's not less than or equal to 5. It's 0 to strictly less than 5. Okay. So we want to go with option 2. Okay, option 1 is a no. Let's go with option 2. And you really don't have to write your bins out. You'll just put them on your axes, okay, when you write them. But we'll have them here. So before we do that, we need to figure out how many individuals are in each bin. So it's going to take some time, but you just pause the video and find the count of individuals. Just the count, the frequency, the actual number of individuals in each bin. Pens here. So here we should have 20, 13, 9, 2, 1. Okay, so there's the counts that we should have. So when we find a histogram, or when we draw a histogram, I'm sorry, we need to first label and scale our axes. So let's put our axes on here. We need to label them with our bins. Okay, and then let's see, we go from the lowest count here is 1 and the highest count is 20. So maybe let's just go up to 20 by 5s. Okay, try to make those as approximately even as you can. I'm just kind of eyeballing it, so. Alrighty, and then we're gonna make our histogram. The difference between a histogram and a bar graph. A bar graph, you may remember this bar graph from before. A bar graph has spaces in between each of these. So this is our radio question. You'll notice that these bars are not exactly pushed next to each other. This is a bar graph. A histogram, they go exactly right smushed up next to each other. So from 0 to less than 5, I have 20 states. So we'll make my bar up to 20. From 5 to less than 10, I have 13. So we're going to smush that bar right up against the other one to 13. From 10 to less than 15, I have 9. Smush that one right up there. I have 5 in this one here. I should have made these even, but it's going to be only, it'll be all right. 2 and 1. Okay, so there's my histogram. I have labeled my axes. I've scaled them. The question of which one goes where, and then draw the bars with no vertical space, which we did all of those things. Okay, so the next thing I want to do, and I'm not going to switch over quite to the next page yet, but I want to make a relative frequency histogram. So we're going to use the same bin widths, but now we need to calculate the percents. So if you remember, a relative frequency uses percents, not counts. The relative frequency and percents do mean the same thing. So we're going to find the percents and then make a histogram. So using my same bin widths here, and we need the counts, which I think I did already actually write. I did write the counts on there. Okay, perfect. So we've got the counts already. We need to find the percents. There are 50 states. So to find the percents, we'll just take 20 out of 50 times 100, which is 40%. Okay, go ahead and fill in the rest of the percents there. Should be pretty easy, right? You just double them. Okay, great. So there's my relative frequencies, my percents, and now we're going to dump those onto a histogram as well. It's still called a histogram, it's just a different type of histogram. So we're going to want to do the same thing that we did before, where we have our axes. They should be the same here. Yeah, we got lots of space. My percents go from 2 to 40. So maybe instead of jumping by 5s, I'll jump by 10s. Same thing as before. This one goes to 40%. This one's 26%, 18%, 10%, 4%, 2%. And that's going to be my histogram. Oh, sorry, it's not clear. There it goes. So there's going to be my histogram for my relative frequency histogram for the same data. Okay. So what I want you to do is compare these two histograms. So we've got this guy. We've got this guy right here. Do you notice anything kind of cool? Ultimately, it's the exact same shape, right? Really, the only thing we've done is we've stretched our axes, this axis only, by a factor of 2. This axis didn't change at all. So these are technically 2 times higher, but they're basically the same shape. okay, which is kind of cool. What is that shape? Which direction is it skewed? More data over here. The tail trails off to the right, so it's going to be right skewed. Okay. So what do we notice down here? They should be the same shape. Our axes are different, but let's go ahead and compare. And let's talk about all of these two things, okay? Now, here's the reality. It says compare. Well, guess what? It's the same. So let's just analyze this graph since it's easier to see. We're not going to use our comparison word because where they are the exact same. The shape we said was right skew. Are there any outliers here? Not really. It is skewed. Okay, so I'm just going to write no outliers. We don't want to forget that, okay, because we still do need to mention that there's no outliers. That's just the fact there's no outliers. Okay, so we just say no outliers. Call it a day. The center, we could find the median. We're not quite ready maybe to find the median. The middle 50% of data, well, this is 40%. And if you add this, you're going to get up to 66%. So 50% is going to be somewhere in the 5 to 10 range. Okay. And then the spread, we do have those actual numbers. So let's figure out the range. And the range goes from, oh boy, California was 27.2 and West Virginia was 1.2. So my range would be 26%. Okay. Remember, the range is an actual number, not the range of values. So that is a histogram, a frequency histogram, and a relative frequency histogram, and then kind of seeing the comparison between those two things.